In this video, we're going to play some more with the properties of exponents. We're going to focus on solving equations and using these properties to help us do that. Two properties that are going to really help us are these two on the bottom. The fact that if I have two numbers are equal, then if I raise them to the same power, they should still equal the same number. And the other one is if I have two numbers, if I have the same base raised to different powers, and that base is not 1, then that means that the powers have to be equal. So those are one of the things that we can kind of use to help play with and solve some example problems. So let's go ahead and look at some. This first one, we have 5 to the third equals 25 to the x. Now, we're going to be taking a look at this property right here, because if I can get both of those to have the same base, then I can make my exponents equal. The nice thing is I look at 25, and 25 equals 2 squared. So I can rewrite this equation and say 5 to the third equals 5 squared to the x. Or, now going back to my properties, I have let's see, I have a power to a power. So I can rewrite this as 5 to the third equals 5 to the 2x. And now, since my bases are equal, my exponents are equal. So 3 has to equal 2x. So x is going to be 1.5. And I can check this. I can go ahead, plug 1.5 in for x and see, does 25 to the 1.5 power actually equal the same number as 25 to the third? Now when we look at this next one, we got some funky things going on because we threw in a fraction here. Oh, joy of fractions. But again, we're going to come back and see if I can use this property, because 16 is 2 to the 4th power. So I can rewrite this as 2 to the x. Quit doing this. 2 to the x equals 1 over 2 to the 4th. Well, I need the same base. My base here is in a fraction. What do? Well, this is where I can take use of my negative exponents. I can rewrite 2 to the 4th as, or 1 over 2 to the 4th as 2 to the negative 4th. So 2 to the x equals 2 to the negative 4th. And now, same base. Exponents have to be the same as well. That looks weird. Let's fix that. X equals a negative 4. Now, last one's not quite as nice. Gut reaction says, hey, let's divide each of those by 8. We got 8 and 16. 16 is just 2 times 8, but it's not a power of 8. And I need to have the same base. So it has to be a number to the power because I got stuff in the exponents. My x is in the exponent. But they are related because 8 just equals 2 to the 3rd power, and 16 equals 2 to the 4th power. So I can, in this case, rewrite both of these. And I'm going to get 2 to the 3rd raised to the 2x power equals 2 to the 4th raised to the 3rd power. So now again, using the power of a power, I got 2 to the 6x equals 2 to the 12th. And now again, I got the same base. Bases are the same, so the exponents are the same. 6x equals 12, so x is going to equal 2. This works great if I can get both sides of the equation to have the same base. If I don't, then I got to play other games. And that's some of the things we're doing in this unit. Now let's look at, we can use some of the other properties. What other things can I do here? X to the third equals 50. Now my variables, actually in the base. This one is a power function. It's x to a power. It's not x as the exponent or x as a power. X is in the base. But we can still use the properties of exponents because I want to get down to x equals, and that has x to the third. So I need that down to x to the 1. Well, how can I change the exponent? Well, I can either do it by multiplying by another x, so I can use the addition property and I can add a negative 2 to it to get rid of that, but that means I got another x in there. That's messing things up. Or I could use the multiplication. I could raise it to a power, then I could multiply. How can I multiply 3 to get 1? I multiply by the reciprocal. So I'm going to take this. I'm going to take my x to the third equals 50, and I'm going to raise both sides to the 1/3 power. Because now I can use the power of a power and say 3 times 1/3 is 1. Now I just have to get 50 to the 1/3 power. But you say, I have no idea what that 1/3 power means. I don't know how to do that. Well, fortunately, your calculator does. So we'll plug that into the calculator, and we get that's going to be approximately 3.68. So let's see if we can do some more with this. On this next one, x to the negative 1/2. Negative 1/2, give me a break. Yeah, we got negatives in here. But we can do the same thing. What do you multiply negative 1/2 by to get 1? You multiply it times its reciprocal. So, but to multiply an exponent means you have to raise it to that power. So I'm going to raise it to the negative 2 power. So I'm going to get x equals 1/48 squared. Or, and again, using my trusty calculator, 1/48 squared would be 0.000434. Stay put, please. The joy of technology, right? Okay. For my last problem over here, 3 to the 5th plus 7 equals 248. Well, I want to get it down to something like one of these where I have x to a power. Then I can raise it to the reciprocal power and undo that. So I'm just going to use my basic algebra. I'll subtract 7. I got 3x to the 5th equals 21. I'll divide by 3. X to the 5th equals 807. Oh, that low. Lovely. So now I got that 5th power. Now I just have x to the 5th. I can raise it to the reciprocal power, so I can take 5 times 1/5 to get 1. I get x, and I just have to take my 807 to the 1/5 power, and that gives me about 3.81. So with these properties of exponents, it now helps us solve some problems that were a real royal pain before, that all we could do was guess and check.